Oh. Now, might we be going tomorrow?
Yeah.
I didn't think that was possible, but my fourth period almost has me believing that because we looked at the radar and it's supposed to rain tonight some more. So who knows? Now, just in case we are taking our test tomorrow, let's make sure that you know the answers to all the problems. So I realized that yesterday you probably got half or more of this done, but maybe you didn't get the whole thing done. We're gonna go through all of it right now. So take good notes on how to do these, because guess where I go to get the problems for the test? From the review. Yeah.
Okay, so
Let me give you a little secret on how I make the test. I probably shouldn't be giving you this secret, but all I do, like, let's say number 5, whatever number 5 is on the test, instead of 3 over x plus 7, it's going to say, I don't know, 5 over x plus 9 equals 9 over x plus 11. It's going to be the same problem. I just change the numbers a little bit. That's all I do. So if you do a good job and take good notes on how to do this, you're probably going to do pretty well in the test tomorrow. Yes, sir.
So I also looked at 20 and 21.
Yes.
Don't you just get the answer of 20 from 21?
I don't know. 20 and 21, 21 and 22. We'll get there, hopefully. Let's see, how much time do we have? We have until 1:25. I think we'll get there. Let's get started. On your mark, get set, go. Add and subtract. Here we go. Tell me what the common denominator is. 7x. Take everything from the first fraction and write that in for the denominator, and then only put things in from the second fraction that aren't already in there. Is the 7 already in there? Yes. Therefore, your common denominator is ready to go. Now multiply each numerator by what its denominator is missing. What's that denominator missing from that denominator? Nothing. So what do I have to multiply that 3 by? Nothing. So write down 3 plus, and then what's this denominator missing? The x. So what do I got to multiply the 5 by? And you're done. Now you want to simplify. And what are people going to be tempted to cancel out? Yeah, don't you really want to cancel that x with that x? But you can't, because it's next to an addition, right? You can only cancel things when they're next to multiplication. So resist the urge to cancel that out. All right, this is what you guys called something flip something. What did you keep, change, flip? All right, so keep, change, flip. Right? Okay, good. Now, factor everything you can factor. I can't see anything that we can factor except 1, and that's that one. What factors out of there? 3. And what's left over?
X minus 2.
And isn't that nice? Because the next step is to cancel as much as you can cancel. Can I cancel this x plus 2 with that x plus 2? Or I'm sorry, minus 2. Yes. Anything else cancel? No. So now gather up all the stuff on the top. 3 times 1. And gather up all the stuff on the bottom. And that's it. You're all done. How are we doing so far? Now, these are the ones I know you guys got done because, we were all working on these together yesterday. But now this one, you don't have to keep, change, flip, because this means times. I think on the test, it's a little dot, so it won't be confusing. I don't want you to think that that's an X. But can I factor this or this? No. But could I factor that? What goes into 4 and 14? 2. What goes into 3 and 3? 3. So, but you're right, it would be x plus 1 left over, right? Oh, thank you very much. That was almost a mistake, but Mariah caught it for me. So thank you, Mariah, for not letting me make a mistake. So technically that wasn't a mistake, right?
No, it was a mistake.
That was a mistake. Yeah, that probably does count as a mistake. I can't even blame Mr. Vickers on that one. All right, here we go. Now that we've got everything canceled, can I cancel or factored? Can I cancel everything out?
Yes.
What does this 2x minus 7 go away with? And what about this x plus 1? Is there anything left? The 2 and the 3. 2 and 3. How are we doing? All right, number 4. By far the most difficult problem on the entire test. Not even close, because it's an adding and subtracting, and you have to actually do some factoring on this one. So you have to think about this. What two numbers multiply to give you 6? 3 and 2. Then check, do 3 plus 2 give you 5? They do. So now you factored it. Now we want to make a common denominator. Take everything from the first fraction and put it in the common denominator. And then only put things in from the second denominator that aren't already in there. Is that x plus 2 already in there? It is. And therefore, we don't have to put anything else in. Multiply by what each denominator is missing. What is this denominator missing? Nothing, because it has both the x plus 3 and the x plus 2, just like our common denominator. There's nothing missing. So I don't have to multiply that 4 by anything. I can just write it down. 4 plus, yeah, this one is missing something. It has the x plus 2, but it does not have the x plus 3. So I need to multiply that 3 by x plus 3. So looks like this needs to be distributed, right? So that's going to be 4 plus what? 3x plus 9. And that's all still over my common denominator. Is that the final answer?
No.
Almost. Is there anything I could still simplify just a little bit? Yeah, isn't 4 plus 9 equal to 13? So 3x plus 13, all divided by x plus 3. I'm running out of room here, but you get the idea. X plus 2. There you go. That's the answer. Would it be okay to put the 13 first and the 3x second? Makes no difference. Yep, that would be just as good of an answer, but that's a good answer. No, test is going to be just like normal. Now, I should say this, is the test going to be on paper? Yes, because you're going to have to figure this out on paper. And then you're just going to put the answer on the computer. These are going to be so easy, you won't even need to.
If I get it wrong, no, if I accidentally don't do the 4 and the 9.
Oh, you'll do the 4 and the 9. Because you guys never make silly mistakes like I do. Yep, that's it. That's it. All right, let's try this. Now we're done adding and subtracting and multiplying and dividing. Now we're solving. Now, sometimes the reason people have trouble on the test is they have difficulty shifting gears. Like you just got done adding and subtracting and multiplying and dividing. This is totally different now. So don't try to get a common denominator. That's not what you do to solve these. When you see two fractions equal to each other like this, what's the strategy to solve? Cross multiply, right? You want to take this times this and this times this. Hold on just a second. Okay, thank you. All right. So cross multiply. So 3 times x plus 13 equals 9 times x plus 7. If you write that down like that on paper, like a lot of you are just asking, is this going to be on paper or is it going to be on the computer? It's on the computer, but if you write it on paper, you're going to get it right. I think sometimes when people are doing the problems on the computer, they think they have to do them all in their head. You don't. I would still suggest doing the problems on paper and writing them down because that makes them way easier. Now it's just an algebra 1 problem, right? After you cross multiply, this is algebra 1 from here on out. How do I solve this? Not well, okay, wait. No, I didn't even think about that. But this is not the way I would have done it because I'm a creature of habit. But could you divide both sides by 3, get rid of that 3 and turn that into a 3? You could, and you'll get the right answer. But I'm not going to do it that way because it's going to confuse a lot of you. But you could do it that way. What did most of you do at this point? Distribute. Now we're going to get the same answer, but you're going to get 3x plus 39 equals 9x plus, oh boy, 63. Does that sound right? Now it's still an algebra 1 problem, but we do have variables on both sides. So what should we do now? Should we subtract the 9x or the 3x? And it really doesn't matter. I'm going to subtract 3x. But you could subtract the 9x if you wanted to. I'm going to subtract 3x because that way I get a positive over here. I like positives because it's one less thing for my feeble brain to mess up. Now what should I do? Subtract 39. subtract 63. Remember, we're trying to get the x by itself. So don't bring more things over here. Take these things and bring them over there. So on your calculator, since this one's maybe a little tougher, let's take 39 minus 63. You get negative 24. And now we're almost done. What's the very last step? Divide. And there's your answer. If you want to be really confident before you hit submit on the test, could you plug that back in? Yeah. What's negative 4 plus 7? What is it? 3? What's 3 divided by 3? 1. What's negative 4 plus 13? Be positive 9. And what's positive 9 divided by positive 9? 1. So there's no way that can be wrong because we plugged it back in and it works. So anytime you get a solve problem when you're taking a test, that's good news because you can check your answer really easy. All right, let's do number 6. Same thing, cross multiply. X times x minus 4 equals x minus 2 times x minus 3. Why is this one going to be a little more work? The FOIL method, yeah. So this one's going to be x squared minus 4x. That's pretty easy. But this one is going to be x squared minus 5x plus 6. Now I did that part kind of fast. Does anybody want me to explain how I got from here to here?
Yes.
Okay, let's do that. F, FOIL, x times x. What's x times x? X squared. Now, FOIL is the O and the I. The nice part about the O and the I part of FOIL is you can almost always combine those like terms. What's the O part going to give me? Negative 3x. And what's the I part going to give me? Now is the hard part. You got to think in your head, what's negative 3x and negative 2x when I put them together? And that's where that came from. Yep. And then the L part of FOIL is that times that. So I got negative 2 times negative 3 is positive 6. Okay. Yuck. The hard part of the problem is finally over because what's going to happen with this x squared and this x squared? They're going to cancel out. Now it's an Algebra 1 problem. Just like that one over there was an Algebra 1 problem. Remember, we had x's on both sides, so we subtracted 3x. What should we do to this one to make? Add 5x. Add 5x to this side and it disappears. Add 5x to this side and you get 1x. So now what do I got to do to get x all by itself? It's already by itself. Do we have to do anything else? Nope, all done. X equals 6. How'd you do? Okay, because I think most of you got at least this far. Oh, I didn't show my work. Let me just show you what I did. I put plus 5x on this side, right? That would make this one disappear. And then plus 5x on this side. So here, negative 5x and positive 5x, they're gone. So the 6 just comes down here. And negative 4x plus 5x, negative 4 plus 5 is 1. Okay, awesome. Are we ready to move on? All right. Okay. And if I move this and you can't see it, make sure you yell at me so that I move it so you can see it. Invertible, yes or no? Why not? It fails the horizontal line test. If you put a horizontal line, it touches in more than one place. Fails the horizontal line test. Invertible, yes or no? Yes. Invertible, yes or no? Let's try another one. Invertible, yes or no? Why is it no? You're absolutely right. Now think about what the graph of that looks like. Wouldn't the graph of this look like this, right? Is that failing the vertical or the horizontal line test? Yes, it is. How about this one? Yes or no? Yes. Why? It's a straight line, right? If I was going to graph this, it would have a negative slope. It would look something like that. But would you be able to put a, yeah. So even if I don't give you the graph, if you can kind of imagine what the graph looks like in your head, you're still going to get it right. All right, this is what another set of problems that on the last test I noticed, it isn't that you didn't know how to do them, it's that you had trouble shifting gears again. You had trouble figuring out what in the world are they asking for. Here, we're asking for the inverse. This is notation for the inverse. So if I'm asking you to find the inverse, the thing you have to remember about these is you have to swap what and what? Swap X and Y. If you remember that, you're probably going to get this right, because a lot of people got all three of these problems wrong in the last test just because they didn't even know how to start. Just remember, you got to swap the X and the Y around, and then you'll get them right. F of X is just a fancy way of saying what letter? It's a fancy way of saying Y. So when I swap the X and Y, it's going to look like this. X equals the square root of Y minus 6. This says Y, I just changed it to X. That says X, I changed it to Y. If you do that on paper, you're going to get this problem right. Because now you just have to solve it for Y. So Y is not by itself. What do I get rid of first? Not the square, the 6. Because you always undo additions and subtractions first before you undo multiplications and divisions, before you undo exponents and parentheses. It's like doing the, please excuse my dear Aunt Sally, but doing it from the bottom up instead of the top to the bottom. So add 6 to both sides. What is X plus 6? Nope. What's X plus 6? It's X plus 6. They're not like terms. You can't put them together. So X plus 6 is just X plus 6. It's not 6X. You're not multiplying them. You're adding them. And then how do you undo a square root? You square both sides. Excellent. Now that just makes the square root symbol go away. So you get X plus 6 in parentheses squared. If this is multiple choice on the test tomorrow, might it say this? And does that mean the same thing? It does. It means the same thing. What? I'm done. As soon as you get Y by itself, you're done. Yep. Remember, all you're trying to do is find the inverse. You're just trying to get the Y all by itself. Or you could use the Lexi technique, right? Which is what? Flip everything around. Minus 6 became plus 6. Square root became square. Whichever way you like to do it better, you can use the Mr. File method or the Lexi method. All right, here we go. What do I do first? I already flipped the X's. I put X here and I put Y there. Now, last time we got rid of the minus 6. Should we get rid of the plus 5? Why not? It's inside. Yeah, remember, inside of the square root thingy means it's like parentheses. You undo those last. So what do I undo first? The 7th, yes. So I got to take everything to the what power? The 7th power. Excellent. When I take this to the 7th power, I just get Y plus 5. X to the 7th power is X to the 7th power. And then finally, I just need to subtract what from both sides? And what is X to the 7th minus 5? It's just X to the 7th minus 5. Again, they're not like terms. You can't put them together. If you want, you can rewrite it like this, but it really means the exact same thing. So again, I don't think these problems were all that difficult on the last test. I think some of you just weren't sure what to do on the first step. And then you were just like, well, if you can't do the first step right, you're going to have trouble doing any of it right. So if you don't put the bowl down, it doesn't matter how good you pour the milk in the cereal, it ain't going to happen. You got to put that bowl down first. How about this one? X equals Y to the 3rd plus 1. Switch the X and the Y around. Now what? Subtract 1. The 1 disappears from this side. It shows up over here as a minus 1. Now what? Not cube. Cube root. Good. Cubed root both sides. Because that way this gives you Y and you get the cubed root of X minus 1. Which is the right answer. If you want to write it like this, you can. You don't have to, but it really means the same thing. And that's it. Okay. Still doing all right? All right. Next page. These go a little quicker. These were like the IXL assignments. So let's do this here. How are we getting rid of those parentheses? How do you get rid of parentheses? Distribute. So let's see, that's going to be -8 square roots of 2. And that's going to be plus the square root of what? Okay, now simplify. Can you think of a perfect square that goes into 2 or 10? Me either. So that's done. You're all done. Try this one. What's a negative times a negative?
Positive.
Positive. What's a negative times a negative? What's a negative times a negative? What's a negative times a negative? Positive. If a negative times a negative is a positive, then a negative times a negative is a positive. Can you think of any perfect squares that go into 11? What about 110? Neither. All done. Can't do it. There's no perfect squares that go into 110. You'd think there should be. It's such a big number. You'd think there would be a 4 or something, but 4 doesn't go in, 16, 25, none of those go in. So it's, you're done. All right, simplify. What's 9 square roots of 2 minus 4 square roots of 2? Done. 9 minus 4 is 5. That's correct. They are like terms, so you just combine them. Are these like terms? No, but could we maybe get one of them to be like term? Well, let's try. Does anything go into 50? Aha, 25 times what? 2. I know I can't do anything with that, so I'm just going to write it down. I like to underline the things that are perfect. All right, the perfect thing gets to come out. The imperfect thing has to stay in. When this 25 comes out, it's not going to be a 25 anymore. What's it going to be? What is the square root of 25? 5. Now, can you do this next part in your head? When the 5 comes out, it's going to multiply by this. What does that give you? Negative 15. If that confuses you and you want me to write out that step, let me know because I'll do it. It's just that you want me to do that. All right, here's what we did. We took negative 3 times 5 times the square root of 2. Like this, because when the 25 comes out, it's going to come out looking like this 5 right here. And then to get from here to here, we took negative 3 times positive 5. That gave you the negative 15. Now are you done?
No.
Almost. Doesn't this one look just like 15 now? We got 2 like terms. What's negative 15 square roots of 2 plus 9 square roots of 2? Negative 6 square roots of 2. Yeah, so once you finally get all done, then you can simplify those. Okay. All right. 17, solve for x. Does that mean these are difficult? Should you do these totally in your head without using paper? I would suggest no. I would suggest doing these on paper. All right, step 1, isolate the radical. What's keeping this radical from being all by itself on the left side of the equal sign? What? So let's add 7 to both sides. That gives you the square root of negative 7 plus x equals 2. 7 minus 5 is 2. Now what should I do? Square both sides. Right? I take this side and I square it. I take this side and I square it. Now what? What's keeping x from being all alone? Minus 7. What's the opposite of minus 7? Plus 7. What is 4 plus 7? 11. And there's your answer. That's it. As soon as you get x by itself, you know you're done. Is there any part of that you want us to talk about? These take a little bit of work, but when you guys were doing the IXL on this, you guys were saying that these were pretty easy. Now, yeah, if you're really good, you can do these on your calculator, but I'm going to show you how to do them on paper because I don't want to confuse you. All right, let's try to do this one. What should I get rid of first, the 14 or the negative 4? 14. Good. Subtract it from both sides. I get negative 4 and the square root of x plus 13. Don't be afraid to write things down. What is 6 minus 14? Negative 8. Now, should I stop right here and say no solution? No. But we've got a square root equal to a negative. Yeah, it's not going to be negative for long, is it? Because when we divide by negative 4, What is -8 divided by -4? It's 2. So you've got a square root equal to a positive. So there are going to be solutions to this one. What's next? Square both sides. And then what? Subtract 13. Yeah, once you get past the first couple steps, then it ends up being just an algebra 1 type equation, which you guys are really good at. This one's not quite as easy because it has that 4th power, but we have calculators, so we're not scared. What should I get rid of first? The 7. -7 minus 7. The 4th root of x plus 3 equals, let's see, 5 minus 7. -2. -2. Now what should I do? Take both sides to the 4th power. So, all right, I don't know what that is, so I'm gonna do it on my calculator. -2 to the 4th power is 16. All right, we can do that, 16. So that means x plus 3 equals 16, which means x equals how much? 13. Something just went horribly wrong. Do you know what it is? What's 13 plus 3?
16.
What's the 4th root of 16? 4th root, not square root. What times what times what times what is 16? 2. What's 2 plus 7? It's not 5, is it? It's not 5, is it? So this is an extraneous solution. There is no solution. Could we have figured that out earlier? Maybe. Can a 4th root equal a negative? Remember in this step? No, I can't. So that was, don't forget to check your answers to see if there's any extraneous solutions. All right, last one. What do I do first? Cube it. 5x plus 1 equals 64. Because when you cube both sides, you get 64. Does this look like something we can handle? I think so. What do I do now? -1. Divide by how much? By 5. And you're done. I don't think 63 over 5 simplifies. You could check. Is it 12.6? If you want to write it as a fraction or as a decimal, that's totally okay. Yeah, if you wrote 12.6 instead of 63.5, totally okay. Yep. Still good. Yes, either way would be totally cool on the test. Yep. All right, we got about 5 minutes left. We got 2 problems to do. We can do that. Remember when Mr. Vickers was showing you that ACT problem and he just said blah, 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 and he plugged in the numbers into the formula? Or was that me? Okay, yeah, that's right, because he did 7th period that day. The time it takes a pendulum to complete one full swing. Do you know what a pendulum is? Like on a clock? Yeah, it's a little swingy thing on a clock. The longer it is, the more time it takes to do this, right? And the little short one goes really fast, but if it's really long, it takes longer. Here's a formula that figures it out. T is the time in seconds. L is the length of the pendulum in meters. Determine the time for a full swing when this is the length of the pendulum. So what do I plug this in for? L or T? Is that a time or a length? That is a length. So calculator, type in 2 pi times the square root of 1.2 divided by 9.8 equals, it's about 2.2 seconds. How about that? That was fun. Let's do the exact same problem, but instead, this time it says 6 seconds. So where do I got to put that? I got to put that in over here, right? So 6 equals 2 pi square root of L over 9.8. Oh boy, this is going to be terrible. Now, let's do it the McLean way, and let's try to get L by itself. What do I get rid of first? How about the 2 pi? So let's take, on your calculator, do this. 6 divided by parenthesis 2 pi. Parenthesis. Do that first and get an ugly number on your calculator, right? So now you've got ugly number, 0.95, blah, 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 equals square root of L over 9.8. Now square it, take your number and square it. Big ugly number again, 0.91, blah, 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 equals L over 9.8. Careful, times 9.8 equals 8.9. That means that if it's going to take a pendulum 6 seconds for one full swing, that's a long time, right? Does that mean this pendulum is really long? Yes, not 8.9 meters long. That is a huge clock, like Big Ben in London kind of clock. I mean, that's, if it takes 6 seconds for the pendulum to go from here to there, that's a big clock. But story problems, no problem. We're not afraid of story problems. So your only assignment for tomorrow is to ace tomorrow's test.